Previously on Kung Fu Maintenance. Found the solenoid valve that was melted and not working.
You can trip the GFI as well, and this has a GFI. But here's what the solenoid valve should be doing. Rotate it and then pull. Yeah, there it goes. Like a new one, it looks like it's that sleeve that it goes into that melted.
Just don't make them like they used to. Enter dishwasher day 2.
Right here is the capacitor. It's a 10 microfarad capacitor. I actually may be able to just change out the capacitor on the new one. Yeah, I got a comment yesterday about that. Okay, there's the 10 microfarad capacitor. Shout out to Dan Logical Thinking, who suggested that it might be that. I'm going to give that a try. I'll pull that apart. It's just 2 wires here to disconnect. And I'm going to go with that first, and if not, then I'm going to change the motor. Again, it's follow the same deal that I would do with an air conditioner. Disconnect both leads and then discharge across the capacitor just in case to cancel out any fuel that might be there.
Because the capacitor holds a charge after being disconnected.
Unscrew the capacitor here.
Discharging an air-conditioned capacitor is done with an unplugged or disconnected unit, holding only the insulated portion of the screwdriver
Right out.
and bridging the metal leads of the capacitor to cancel out the charge.
And we'll try changing that capacitor, and if not, we'll change the whole motor. Either way is easy, just one. The other one involves a little bit more water and wet dry vacuuming. But this is one screw. And in theory, there we go. One capacitor. Alright. I'm going to try that first and go from there. Let's see. And I actually have my meter. I can test the other capacitor. Here's a new dishwasher capacitor. I'm going to set this to microfarads. This one's a 10. Now we'll see how we go. .01 microfarads. And this is plus or minus 5%. Alright, good.
So here it is at the one to test, and unplug the unit first, then pull the leads, and then I'm going to discharge the capacitor, holding only the insulated portion of the screwdriver. You notice I'm not touching the metal portion of the screwdriver.
That easy to get in there. Pair of needle nose with insulated handles, so that'll work nice and easy to be able to bridge the leads to discharge the capacitor for the dishwasher.
It's likely that the motor windings would discharge the capacitor, but you really don't want to take a chance. You know, you're dealing with water and electricity. You definitely want to make sure everything's unplugged first, and then pull in the seal and discharge in the capacitor. And then here is testing. Again, it probably discharges in the motor windings, but what if a wire burned somewhere and then it still had power applied to it? The capacitor could build up the charge, and it may not be a lot of current, but if water increases the surface area that electricity is able to travel on, and if someone has a weak heart, you know, you mix a little water, a little bit of electricity in just the wrong place across the heart, and boom. So it's just a good idea to take the precautions and discharge the capacitors. It doesn't take much time. It's always just a good safety practice. This one tested good at 10 microfarads, so no need to change it.
One lead to each side, works just like any other capacitor.
I should mention there are some other capacitors for different things that are more sensitive, specialized stuff for special components like stereos and TVs, computer systems, where you'll want to use some type of resistor to slowly bleed off the charge, or, you know, a lot slower, milliseconds, to bleed off the charge. People use a resistor in between so that the screwdriver is just instant connecting one lead to the other side, and it discharges it, and it's very effective. But for sensitive equipment, you don't want to blow the capacitor, and so you want to use a resistor in between. Some people use like a light bulb with one lead to each side, and that way the light bulb dissipates the heat or discharges the capacitor, discharges the energy. This one I didn't need to change the capacitor. I did change it anyway, so I thought I'd leave that in the film. I'll just speed it up a little bit. And that's how you can discharge the dishwasher capacitor. That's how you can test it, change it, replace it, and whatnot. I very rarely have these go out, although it wouldn't surprise me if some dishwashers have been condemned when all that was wrong was the capacitor. Now you know how to test them. And or change it out. If you didn't have a microfarad tester, you could change it out with another dishwasher if you had another dishwasher readily available of the same type. This one did not repair the dishwasher, but I thought it worth showing you on how you can test and replace and change the dishwasher capacitors. And be on the lookout for more Kung Fu Maintenance dishwasher days. They're in the oven as the saga continues.
Got it unplugged.
Got a bit more of an experiment coming soon. Can you replace the dishwasher pump and motor without uninstalling the dishwasher? Can it be done? It's coming soon. A quick search of my YouTube channel, you should be able to find a bunch of material that'll be helpful to your maintenance needs, and links to tools and parts used in the videos can be found in the descriptions below.